In this video, I am discussing 10th standard mathematics, chapter 1, real numbers. Here, ಈಗ prime numbers ಅಂದ್ರೆ ಏನಂತ ನೋಡ್ರಿ. ಇದಕ್ಕ ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳು ಅಂತ ಕನ್ನಡದಲ್ಲಿ ಹೇಳ್ತಾರ. ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳು ಅಂದ್ರ ಒಂದು ಮತ್ತು ಅದೇ ಸಂಖ್ಯೆಯಿಂದ ಭಾಗವಾಗಿ ಇನ್ನಾವುದೇ ಸಂಖ್ಯೆಯಿಂದ ಭಾಗವಾಗದಿರುವಂತಹ ಸಂಖ್ಯೆ. ಅದಕ್ಕೆ ಇಂಗ್ಲಿಷ್ನಾಗ if a number is divisible by 1 and itself is called prime numbers ಅಂತ ಹೇಳ್ತಾರ. ನೋಡ್ರಿ, a prime number is a natural number greater than 1 that has exactly two factors. That means 1 and itself. Examples of prime numbers: 2, 3, 5, 7, 11, 13, 17, 20, 19, 23, 29, 31, 37, 41, 43, 47, and so on. ಇನ್ನು ಅನೇಕ ಪ್ರೈಮ್ ನಂಬರ್ಸ್ ಗಳದಾವು. ಇವಿಷ್ಟು. Here 2 is the only even prime number. 2 ಸಮ ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆ ಆಗಿದೆ. All other even numbers are not prime because they are divisible by more than 2 divisors. Composite numbers. ನೋಡ್ರಿ, composite numbers ಅಂದ್ರೆ ಏನಂತ ನೋಡ್ರಿ. ಇವು ಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳು ಅಂತ. Composite numbers means ಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳು. These are called composite numbers. They have more than 2 factors. ಯಾವುದೇ ಸಂಖ್ಯೆ ಎರಡಕ್ಕಿಂತ ಹೆಚ್ಚು ಅಪವರ್ತನಗಳನ್ನ ಹೊಂದಿದ್ರ ಅದಕ್ಕ ಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳು ಅಂತ ಕರೀತಾರ. ಈಗ ಉದಾಹರಣೆ 4 ತೆಗೆದುಕೊಂಡಾಗ 4ಕ್ಕ 1 ಫ್ಯಾಕ್ಟರ್ ಹೌದು, 2 ಹೌದು, ಮತ್ತ 4 ಹೌದು. ಎರಡಕ್ಕಿಂತ ಹೆಚ್ಚು ಅಪವರ್ತನಗಳದವು, ಆದ್ದರಿಂದ ಇದು ಕಾಂಪೋಸಿಟ್ ನಂಬರ್. ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ತೊಗೊಳೋದಾದ್ರ 6. 6ಕ್ಕ 1, 2, 3, 6. Next 8, 9, 10. These are all composite numbers. Special cases: 1 is not a prime number. It has only one factor. That's why 1 is not a prime number. It is identity number. It is identity number. 1 is neither a prime number nor a composite number. It is multiplicative identity number. 0 is not a prime number. 0 is additive identity number. 2 is the smallest and only even prime number. See, to check if a number is prime, first one, see if it is greater than 1. Next, try dividing it by number less than it, other than 1. If divisible by any such number, not a prime. In these cases, that number is not a prime. Next, very important for your exam purpose. Fundamental theorem of arithmetic. ಇದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ನೋಡ್ರಿ. ಇದನ್ನ ಸರಿಯಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ರಿ, ತುಂಬಾ ಈಸಿ ಇದೆ. Theorem, fundamental theorem of arithmetic. Every composite number can be expressed or factorized as a product of primes. ಯಾವುದೇ ಭಾಜ್ಯ ಸಂಖ್ಯೆಯನ್ನ ಅವಿಭಾಜ್ಯ ಸಂಖ್ಯೆಗಳ ಅಪವರ್ತನಗಳಾಗಿ ಬರೆಯಬಹುದು. And this factorization is unique apart from the order in which the prime factors occur. Example, ಹಂಗ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ ನೋಡ್ರಿ. ಈಗ ಎಕ್ಸಾಂಪಲ್ 12. 12 ಅನ್ನ ನಾವು ಹೆಂಗ್ ಬರಿತೀವಿ? 2 into 2 into 3 ಅಂತ ಬರಿತೀವಿ. 2 2s are 4, 4 2s are 4 3s are 12. ಸರಿನಾ? ಇದನ್ನ ಇನ್ನೂ ಒಂಥರ ಹೆಂಗ್ ಬರಿಬಹುದು ಅಂದ್ರ 2 into 3 into 2 ಅಂತಾನು ಬರಿಬಹುದು. ಅಂದ್ರ ಇದನ್ನ ಯುನಿಕ್ ವೇದೊಳಗ ಇದೇ ತರ ಬರಿಬಹುದು. ಆರ್ಡರ್ ಈಗ 2 into 2 ಅಂತ ಬರ್ದಿದ್ವಿ, 2 into 3 ಅಂತ ಬರ್ದಿವಿ. ಆರ್ಡರ್ ಬೇರೆ ರೀತಿ ಆಗಿರ್ಬೋದು ಅಂತ. Every composite number can be expressed or factorized as a product of primes. ಈ ತರ. And this factorization is unique apart from the order in which the prime factors occur. These are all prime factors. Order doesn't matter here. For example, another example, 2 into 3 into 5 into 7 as the same as 3 into 5 into 7 into 2 or any other possible order in which these primes are written. The prime factorization of natural number is unique. The prime factorization of natural number is unique except for the order of its factors. I already told. Order of factorization is immaterial or does not matter. In general, given a composite number x, we factorize it as x is equal to p1, p2, p3, p4 and so on pn, where p1, p2, p3 and so on pn are primes and written in ascending order. See here, ascending order. ಏರಿಕೆ ಕ್ರಮದಲ್ಲಿ ಅಂತ. This is p1 less than or equal to p2 less than or equal to p3 and so on pn. If we combine the same primes, we will get powers of primes. See, for example, take 12. N x here 12, 2 into 2 into 3. This can be written as powers of 2 appears in 2 times, therefore 2 raised to 2 into 3. This type. Example, 32,760 is equal to 2 appears in 3 times, 3 appears 2 times, 5 into 7 into 13. That means 2 raised to 3 into 3 raised to 2 into 5 into 7 into 13. Once we have decided that the order will be ascending, then the way the number is factorized is unique. This method is also called the prime factorization method. Example, consider the numbers 4 raised to n, where n is the natural number. Check whether there is any value of n for which 4 raised to n ends with the digit 0. See solution. ಈಗ solution ನೋಡ್ರಿ. If the number 4 raised to n for any n were to end with the digit 0, then it would be divisible by 5. ಅದು 4ರಿಂದ 5ರಿಂದ 0ಯಿಂದ ಎಂಡ್ ಆಗಿತ್ತಂದ್ರ 4n ಅನ್ನೋದು 0ಯಿಂದ ಕೊನೆ ಆಗಿತ್ತು ಅಂದ್ರ ಬಿಡಿ ಸ್ಥಾನದಲ್ಲಿ 0 ಇತ್ತು ಅಂದ್ರ ಅಂತ. ಅದು 5ರಿಂದ ಡಿವೈಡ್ ಆಗುತ್ತ. That is, the prime factorization of 4n would contain the prime 5. This is not possible because 4n can be written as 2n. So the only prime in the factorization of 4n is 2. So the uniqueness of the fundamental theorem of arithmetic guarantees that there is no other primes in the factorization of 4n. So there is no value for 0, ends with 0. No value for n, 4n ends with 0. See. Or another method, that was one method. Another method is put values for n. Here 4n. Take values for n. For n is equal to 1, 4n is equal to 4. For n is equal to 2, 4n is equal to 4 into 4. 4 4s are 16. Next, for n is equal to 3, 4 is equal to 4 into 4 into 4. It gives 4 4 the 16, 16 4 the 64. For n is equal to 4, 4 raised to 4 means 4 into 4 into 4 into 4. That means 64 into 4. 64 into 4 means 4 4 the 16. Carry 1. 4 6 the 24 plus 1 25. 256. This is 256. See here, for values of n here 1, 2, 3, 4 and so on. For odd values of n we get 4. For even values we get last digit 6. See, 4 we get 6. For odd values we get 4. Therefore, no value of n we get 4n and with 0. This was the conclusion. This much for in this video. If you like the video, hit the like button. Subscribe this channel for more videos.